Before we learn the ray diagrams, let us first learn the behavior of certain rays. First we learn a ray parallel to the principal axis. Here is the principal axis. So this is the principal axis, the line passing to center of curvature and the pole. Center of curvature and the pole. Now we are taking a ray that is parallel to the principal axis. So this is a ray that is parallel to the principal axis and is incident on the mirror. Now after reflection, this ray will always pass through the focus. So here we have the focus, and a ray that is parallel to the principal axis always passes through the focus. Now, if we want to indicate the angle of incidence and the angle of reflection in this figure, all we need to do is join the center of curvature to the point of incidence. And is this is the normal. When you join the center of curvature to the point of incidence is the normal. Now you know what is angle of incidence. Angle of incidence is the angle between the incident ray and the normal. So the angle between incident ray and the normal is this angle here. We'll mark this as I. And the angle of reflection is the angle between the incident reflected ray and the normal. So here is a reflected ray and this is the normal. This is your angle of reflection. So here we have marked angle of incidence and this is the angle of reflection. Now when it comes to convex mirror, we'll first mark the principal axis, center of curvature and the pole. This is where your principal axis, a line passing through the center of curvature and the pole. And here we are studying about a ray that is parallel to the principal axis. So this is the ray parallel to the principal axis and is incident on the mirror. After reflection it will diverge, because remember convex is a diverging mirror, and it will diverge and it will move away in this manner. But as it diverges, it appears to come from the focus. Here is a focus. Now here again let us mark the angle of incidence and the angle of reflection. To know the angle of incidence and reflection, we must first draw the normal. To draw the normal, we join the center of curvature with the point of incidence. That line is the normal. So here we join. This is the normal. Now angle of incidence is the angle between the incident ray and the normal. So we have the incident ray here and this is the normal. So this is our angle of incidence. We'll call it I. Angle of reflection is the angle between the reflected ray and the normal. And this is now angle of reflection, that is R. So in all these cases, angle I that we have marked in blue is the angle of incidence, angle between normal and incident ray, and what we have marked in yellow is the angle of reflection, that is angle between reflected ray and normal. So a ray that is parallel to the principal axis always passes through the focus. Next we will see how a ray passing through the focus of a mirror after reflection, what would be its path. So first we'll mark our principal focus, our principal axis. So here is the pole, here is the center of curvature, and the line passing through the center of curvature and the principal pole, and the pole is called the principal axis. and here in halfway we have the focus. Now this ray is coming through the focus. So here's a ray coming through the focus. After reflection, it goes parallel to the principal axis. So when it comes like this to the focus, after reflection it goes parallel. Now it's time to mark the angle of incidence and the angle of reflection. So we first draw the normal. To draw the normal, we need to join the center of curvature to the point of incidence. That is our normal. So here is center of curvature to point of incidence is the normal. Now the incident ray is the angle between the incident ray and the normal. The angle of incidence is the angle between incident ray and the normal. So this is our angle of incidence. We put it as I. And angle of reflection is the angle between a reflected ray and the normal. So this is the angle of reflection. Here for the convex mirror, we have to draw the principal axis. To draw the principal axis, we join the pole with the center of curvature, and that line gives us the principal axis. Here we are studying the ray that is passing through the focus. Now the focus in the concave convex is behind. So we take a ray that is heading for the focus. Here's a ray that is, if produced further, it would have passed through the focus, and after reflection it goes parallel. So a ray that is heading for the focus, after reflection it goes parallel. Now to find the angle of incidence and the angle of reflection, we have to draw the normal. So to draw the normal, we join the center of curvature to the point of incidence. That is our normal. So here is the normal, joining the center of curvature to the point of incidence. Here is our normal. Now for incident, angle of incidence, we have to join. It's the angle between the incident ray, which is here, and the normal. So this is angle of incidence. And for angle of reflection, it is between the reflected ray and the normal. So this is angle of reflection. So in both these cases, we had this green was the angle of, we called it as I, it was angle of incidence. And the yellow, that was angle of reflection. So a ray that is passing through the focus, that is coming out through the focus, after reflection will go parallel to the principal axis. Ray passing through the center of curvature. So here is the center of curvature, and a ray passing through the center of curvature is passing along the normal. See here, the normal also will be at the same point, because you know what was the normal? The normal was the line between angle of incidence and the center of curvature. So a ray passing through the center of curvature is going along the normal. This is the normal. Now in this case, the angle of incidence will be 0 and the angle of reflection should also be 0. So the ray that comes in will retrace its path. It will go back the same way. So let me explain again. This is a ray that is coming in from the center of curvature. It hits the mirror. and when it is reflected it will go back the same way. Now for the convex mirror, we have the center of curvature here, and the ray is heading towards the center of curvature, and the point of incidence is out here. The normal will be the point of incidence and the center of curvature. So this will be your normal. So the ray is coming along the normal. So after reflection, it will move along the same path. Here too, the angle of incidence is 0 and the angle of reflection is 0. In both these cases, the ray falls perpendicular. The ray is perpendicular to the mirror. We'll just summarize what we have learnt. There were 3 rays. We learnt one that went parallel to the principal axis, then another that went through the focus, it passed through the focus, and the third ray that came from the center of curvature. How did these rays behave after reflection? The one that went parallel after reflection went through the focus. The one that came from the focus after reflection went parallel. And the one that came through the center of curvature retraced its path. This was for concave. Now let us see the rays for convex. Again we had 3 rays. One ray which was parallel to the principal axis, the other that came heading for the principal focus, and the other one, the one heading for the principal focus would be in this way, here, like this. What I did earlier was center of curvature, and the other one, the third one, was heading for the center of curvature. Now, how did these 3 rays behave after reflection? The one that is parallel after reflection would diverge. It would appear as if coming from the focus. The one going to the focus after reflection would go parallel to the principal axis, and the one heading towards the center of curvature after reflection would retrace its path. Here's the case for any ray, not any special ray. So in this case, the ray is now, it falls onto the mirror. When it reflects back, always the angle of incidence will be equal to the angle of reflection. So here it comes out, reflects in this way, in such a way that this angle of incidence will be equal to the angle of reflection. Same thing for the convex mirror. If a ray falls on the convex mirror, is incident on the convex mirror, after reflection it will move away. But always the angle of incidence will be equal to the angle of reflection. Angle of incidence will be equal to angle of reflection. Let's learn the image formation of an object kept at infinity for the case of concave mirror. So first you need to draw your concave mirror like this. Here is your pole. This is the center of curvature, and halfway between center of curvature and pole is the focus. Now rays coming from infinity are considered to be rays parallel to the principal axis. So here's a ray coming from infinity parallel to the principal axis, and you know after reflection they pass through the focus. This ray again parallel to the principal axis, after reflection will pass through the focus. So the image is formed at the focus. While drawing these ray diagrams, you got to take your compass, keep the pointer of your compass at a place and take a convenient radius, and after you take that convenient radius, you draw an arc like this. Now this line here will be your principal axis, this is your pole. If you have taken your radius, say 8 centimeters, halfway will be your focus, that is 4 centimeters will be your focus. So at 4 centimeters here you will mark your focus as F. This is your center of curvature. And then you go ahead and draw your rays parallel. After reflection will come through the focus. So they will meet here at this focus. That's where your image is formed. So the nature of the image is highly diminished. It's real because the rays actually meet. It's inverted and formed at the focus. Now for the object beyond center of curvature, first you need to keep your compass at C, and with a convenient radius you draw the mirror. After you've drawn the mirror, you draw the principal axis. The principal axis is a line passing through the center of curvature and meeting at P. Here is your object. This is your object, and from this object you always have to take two rays. One ray parallel to the principal axis and the other ray passing through the center of curvature. Now the one that goes parallel to the principal axis, you know, after reflection passes through the focus. So this ray will pass through the focus, and the one going through the center of curvature here will retrace its path. And if you have seen, both these rays now meet at this point here. So this will be your image. A dash, B dash will be your image. So the nature of the image, it's between C and F, diminished, inverted and real. So to draw this again, I repeat, you take a center here, a point with your compass, you draw a semicircle or an arc. The next you join this center of curvature to the pole P. Now you have to keep your image beyond C. So your image will be somewhere, your object will be somewhere here. From here draw two rays. One ray that is parallel and one ray that goes through the center of curvature. The one that goes parallel will pass through the focus. Your focus will be somewhere midway. Here will be your focus, half of your radius of curvature, and here we will have, this will go retrace its path. And they will meet somewhere here. This is where your image is formed. So here is your image. Now object at center of curvature. So here is the center of curvature and the object is kept exactly at the center of curvature. So here is the object. From here we are going to draw two rays, one that is parallel to the principal axis and the other one that is passing through the focus. I'll take that in another color, passing to the focus. Two rays. The one that is parallel to the principal axis, after reflection will go through the focus, and the one that is going through the focus after reflection will go parallel. So you have the first ray that went parallel, after reflection it went through the focus, and the one that went through the focus after reflection it went parallel. And if you see, the image is now formed exactly at C. So this was the object here, and the image is formed here. Same size, real, inverted at C. So for the image, it's formed at the center of curvature. It's real, inverted, and of the same size. So I repeat again, you will take your compass at a particular point, you will draw your arc, and then at the center of curvature, you will draw the object. Halfway between the center of curvature and the pole, suppose you have taken your radius as 8, at 4 will be your focus, halfway here. And then you draw two rays, one ray that is parallel and another ray that passes through the focus. And you know how these rays behave. The parallel will go to the focus and the one which is through the focus will go parallel. And then you will find here, and this one will go parallel, and it almost will meet at this point. If your diagram is correct and you do it as per measurements, you will get a diagram something like this. Object between the center of curvature and focus. So here is the center of curvature, this is the focus, and the object is kept between the center of curvature and focus. So here is the object. So first you keep your compass at the center of curvature and you draw the mirror. So this is the entire mirror that you will draw. You will mark your focus, and now from the object you keep two rays. One ray will be parallel. You will take one ray that is parallel, and the other ray you will take passing through the focus. The ray that is parallel, after reflection, will pass through the focus, and the one that is going through the focus after reflection will go parallel. Now both these rays will meet at this point. So here is where the image is formed. So this is the image here. So I repeat again, the ray that is parallel will go through the focus, and the ray that has gone through the focus after reflection will go parallel. So the nature of the image in this case, here it will be formed beyond the center of curvature. It's magnified, real, and inverted. See here, the object was kept between C and F, and the image is formed beyond C, this side. Image at focus. So here the image is kept at the focus. So the rays that emerge through the focus after reflection, they go parallel. So this ray will go coming to the focus, after reflection it goes parallel. And here two rays that are passing through the focus, after reflection will go parallel. So object that is kept at the focus, the image will be formed at infinity, because if you see these rays are not going to meet. So we imagine or we assume they meet at infinity. So image is formed at infinity, it's highly magnified, real, and inverted when the object is kept at the focus. So it's the object at the focus, not the image. When the object is kept at the focus, the image is at infinity. Here we'll see the object kept within the focal length. Now what do you mean by within the focal length? Here is the focus and here is the pole. So the object is kept within this focal length here. If you notice, it is kept at this point. Again from here we take two rays. We take one that is parallel to the principal axis, and we'll take another that is coming from the center of curvature. So here it goes straight down here. So the one that is parallel to the principal axis, you will find it will go, after reflection, it will pass through the focus. So it comes parallel, it goes through the focus. The one that comes from the center of curvature over the object, it will retrace its path. And here they've drawn another ray, and that is ray where angle of incidence you make equal to angle of reflection. Now all these rays are diverging, and then if you produce these rays backwards, they appear to come from this single point. Now this image, this is the image, but it is behind the mirror, and it's much enlarged, and because it's behind the mirror, the rays actually don't meet. It's a virtual image. Let me go over it again. So first you keep the object within the focal length. What you mean by within the focal length? Here's the focus, here's the pole, and within this focal length you have to keep your object. So we have now in this case kept our object at, this is our object A. From there we draw three rays. First we draw a ray that is parallel, then we draw a ray that is coming from the center of curvature. Here it comes from this, in this straight down here, and then a third ray you draw, just any ray from the head of the object to this point at the pole. Now let's see how these three rays behave. The ray that is parallel, this ray that is parallel, after reflection will go through, here it will go through the focus. Actually this is a little wrong. The focus should have been somewhere here. Then the ray that is passing to the center of curvature will retrace its path, and this blue ray will now move in this direction, so that the angle of incidence equal to angle of reflection. Now all these three rays, when you produce them backwards, they will not meet in the front because they are diverging. When they produce them backwards in this manner, you will find they appear to meet at this point here. So here is the image. I am doing a dotted image because the rays appear to meet. They don't actually meet, they appear to meet. So the image is, you can say, magnified. It's magnified, virtual, erect, and formed behind the mirror. Here are some examples where we use this concave mirror. You can here see this lady doing her makeup, and the image formed in the mirror is so magnified. It's erect, virtual, and magnified. So this concave mirror is used as a shaving mirror. Here also in another picture you can see this man shaving, and his image in the mirror is so much magnified. Here he is using a concave mirror and he stands within the focal length, so he gets a magnified, virtual, erect image.